situations where the behavior can be modeled by like an exponential or logarithmic function. And then we're going to look at like how to do some problems based on that. So we have like a couple of different scenarios. So we're going to look at sound. We're going to look at earthquakes. We're going to look at chemistry. And we're going to look at like some physics. What you looking for, bud?
Do you have line paper?
I don't have any lined paper. I have that blank paper sitting there. So these are going to be the 4 scenarios that we're going to look at. So the first one we're going to look at is sound intensity. Sound intensity is measured in the unit called decibels. And the formula we use, or we can use to calculate the sound intensity, is beta is equal to 10 times the log of I over I naught, where beta is just going to be the number of decibels. I is the sound intensity, which we measure in watts per meter squared. And I naught is a constant. It's 10 to the negative 12th watts per meter squared. And this constant represents the threshold of human hearing. Basically like what's the quietest thing that the average person can hear. Obviously that varies a little bit. Some of us are deafer than others, but yeah, you know. It's all that earbud time. Yes, sir.
So for the beta one, is it I over I?
That's I over I naught. So like the 0 subscript is all part of that name. So like the numerator is I and the denominator is I naught is the way you read that with the 0 subscript. But those are the letter I's, yes.
Okay.
Is that everybody cool?
Yeah.
So is like beta hypothetically just like X?
Correct, yeah.
Explain that role.
Yeah, it's like, well, I would think about beta more like your f of x,
All right.
and your capital I is like your x.
All right.
So like the cap I is like your independent variable, and the beta is like your dependent variable. So it's more like a function. Does that feel pretty good?
Yeah.
Okay. So let's look at a couple of story problem situations. So here it says, given that the sound intensity of busy city traffic is approximately 10 to the negative fifth watts per meter squared, what is the measure of the busy city traffic in decibels? So it's asking for decibels, so we want to solve for the beta. So this value is my I, right?
Mm-hmm.
So we would say that beta is equal to 10 times the log of 10 to the negative fifth over, and what is I naught? That's not given to me anywhere in the problem.
It's a 10 negative 12.
Yeah, that's a constant. Very good. And now you could type this into your calculator, but we don't really need to do that. We can do it by hand. I'm going to do it that way just for practice sakes. How do I, yep. So Bloom says that to divide two exponentials with the same base, we subtract their exponents. So that's going to turn into 10 to the negative 5 minus a negative 12. Minus a negative is the same as plus. So negative 5 plus 12 is 7. So far, so good. What is log of 10 to the 7th going to be?
Isn't it just 7 log?
No. It's just 7.
Oh.
Why?
Because log is already log 10.
Log is log base 10. So since the exponent base is the same as the logarithm base, those will cancel out. So this turns into 10 times 7, or 70 decibels. Again, you could have typed that whole mess into your calculator and just pressed enter. That would have been fine. I'm just doing it by hand so we have a chance to review some of these finer points, because it's been a minute since we've sat down and done anything together between the AP test and like a work day and a, Delta math time and stuff. We've just,
Log is always log.
if it's just written as log with no base there, it is 10. Yes. That's called the common logarithm, is when we don't write a log there, we assume it's base 10. That's what your calculator does as well. If you see the regular log button on your calculator,
Okay.
that's what that means also. Everybody cool? Okay. Let's look at the next situation here. So this one is about the Richter scale. Those of you that took earth science, what's the Richter scale measure?
Earthquake.
Earthquake intensity or magnitude, right? The Richter scale is designed to register the magnitude of earthquakes. So we measure that with the equation R is equal to A over T plus B. So the little a is the amplitude in micrometers of the vertical ground motion at the position where the earthquake is measured. I'm just describing to you what this is, so when we read a story problem, you can figure out like, oh, what variable does this need to go with, right?
Boom, bang, pow.
Yes, boom, bang, pow. So it's basically measuring how much up and down the ground is moving where you're measuring it at, right? T is the period of the associated wave. What does that mean? What's the period of the wave? So it's going to be like, how long does it take to do one up and one down, right? So you start off at level, it goes up, it goes down, it goes back to level. That's one period. So it's measuring how long.
Again, A was up or down.
Right. Yep. A is how much up and down motion you have. That's correct. And B is a constant that associates the weakening of the wave for how far you get from the epicenter. Because more often than not, when you're measuring an earthquake, your device that measures it isn't going to be at the center of the earthquake, at the most intense place, right? What the B is, it's a correction factor that says, oh, you're 8 miles from the epicenter, so we have, like, it didn't feel very strong because you're pretty far away. Here's a correction factor to kind of like allow you to, okay, at the worst spot, this is what the strength would have been, right? It's just like a correction factor.
So would we always get the B? Or?
So the B would be something that would be given to us, or it would be something where like you kind of don't need it.
All right.
Okay. So that would have been something that scientists would have found like empirically over time, like by measuring an earthquake at a bunch of different places and coming up with like a model and being able to go, okay, so like as the further you get away, the intensity kind of dissipates like this. Does everybody feel okay about this? Yes, sir.
It's a constant. It's like,
A constant
yeah.
means that it's not a variable. It means it's always the same thing. Like in the previous example, the I naught is a constant because I naught is always 10 to the negative 12, right? In here, these could potentially all be different, right? A is the up and down, that should be different. T is the period, like how fast up and down it's moving, that can be different. B is a correction factor associated with how far you are away from the epicenter, that could be different. So like all of those things could be variables in this sense. Now, real quick here, just as an aside, like what kind of numbers do we use to measure the magnitude of an earthquake?
Use the UN.
No, but like you've heard of earthquakes, right?
Yeah.
And like they say, oh, that was a magnitude,
6.4.
right, like 6.4, like something like that, right?
Yeah. 1 to 10 scale.
Yes, okay. That's the Richter scale, yep. And so how much more powerful is like a 2.0 earthquake than a 1.0 earthquake?
So like 10 times.
It's
31.
it is yeah, they are it's 31 is oddly specific.
Isn't the constant thing 10 to the negative 31st? I did that on my Richter scale now. You put it to the 30. I'm not crazy, actually.
24.
Right now I'm thinking you're crazy. Right?
I'm gonna find it.
So
We're in the street. It's
Yeah. 24.
I got negative,
24 in your street.
I got negative 5.
Oh.
Oh, no.
It's by always
Oh,
You put a
no.
negative for
Oh, no.
what does she have to do with the information?
I won't.
So like a magnitude 2 is like 1 order of magnitude greater than a magnitude 1,
Yeah.
right? When we say order of magnitude, we mean like a factor of 10. So like a magnitude 2 is 10 times more powerful than a magnitude 1. But like a magnitude 10 is 10 to the 10th more powerful than a magnitude 1. So like the growth in between them is exponential. Like there's a 10 squared is the times more powerful like a 1 than a 3.
Oh, so it's like,
Or a 3 than a 1, right?
Just 10 times.
so it's pretty much just the exponent.
The difference between them
Yeah.
is like the power of 10.
All right.
Yes.
I just want to say, so people don't think I'm crazy, I looked up the notes. It says, increase by one whole number on the scale is increase in energy by 31. So it's not increase
Right.
in,
Yeah. Yep. So that's,
so that's where I got 31.
yeah,
All right,
okay.
Not crazy anymore.
Not crazy.
For being my 96 in earth science.
I respect your street.
All right.
That street is wrong.
Let's do an example here now. Okay. This one says the infamous San Francisco earthquake had a Richter scale magnitude R of 7.5. How many more times severe was the most severe earthquake ever recorded? The 1960 Chilean earthquake that had a Richter scale magnitude of 9.5. So when we talk about severity, what we're going to talk about is the up and downness, right? Like how much more rocking was one earthquake than the other. Everybody's okay with that? So notice that we weren't given a lot here. So I know R1, if I just plug this in, and that should be, all of that's going to equal 7.5. And we can say the same thing for R2. Okay. Now here comes the tricky parts here, because that's Mr. Kulik's gonna talk through some assumptions we can make, right? So that number B at the end is a correction factor based on like where you're doing the measurement and then it's like correcting it to like how much worse would it have been at the epicenter. So if I'm reporting to you the Richter scale measurement, that correction factor's already been applied to it, right? So in a sense, the B's can just be zeros, because I've already applied the correction factor, which is basically meaning that 7.5 and 9.5 would be equivalent of just measuring them at the epicenter. So those can just go away. Is that okay with you guys? You guys get what I'm saying there? What's up?
I got you.
Okay. You both said it at the same time twice, and it's hard to pick out. Okay. So when I want to find like this relative severity, basically I'm going to want to look at the difference between these two earthquakes, right? So I'm going to do this. So R2 minus R1 is just 2, right? Because 9.5 minus 7.5 is just 2. And then I can use the quotient properties for logarithms, since those are the same log. To write it this way. And I know that I can divide two fractions by multiplying by the reciprocal. Well, they're different coefficients, but we're going to make an argument in a second about that. Okay, so what we're going to do now, T is the period, right? That's just the amount of time. It's going to be a very small number, right? For the amount of time it goes from like level up, down, level. So small, in fact, that like the difference between these are going to be pretty negligible. So for our purposes, we're just going to assume that those two things are equal, so that fraction just kind of cancels out. So what do we have left here? Okay. So what I'm going to do next is I'm going to get rid of the log. What do I have to do to both sides to get rid of that log? A log isn't going to cancel out another log. You could use the definition of a logarithm here, you sure. The way I like to think about it is I'm just going to use the exponent base that matches the log base. What's the log base here? 10. So I would do exponent base 10 to both sides. That's how I like to think about it. So those guys would cancel. Everybody's good with that? And then if I just multiply both sides by A1, we'd say the Chilean earthquake is 100 times more severe than the San Francisco earthquake. Since the Chilean amplitude was 100 times the San Francisco one. Notice that I didn't actually solve for A1 or A2, but the question didn't actually ask for that either. It just asked like how much more intense was one than the other. Now I could have found that intensity by solving for each one of them, but I didn't have enough information to actually do that. So instead what I did was just find the relationship. Caden?
Where did you get the 10? When you made like 10 exponent?
So I wanted the exponent base that I used to match the log base.
Yeah.
Since that was log base 10, I chose to do exponent base 10 to both sides.
Oh, because it would cancel.
Because then it would cancel the log. Exactly, yes.
So then what did it say at the bottom?
The Chilean earthquake is 100 times more severe than the San Francisco earthquake, which was just me answering the question that was posed in words, right? I had the symbols all there, but sometimes that's not very satisfying if it's just all symbols. Everybody so far so good? Okay. The next situation is a chemistry situation. So you guys talked about acids and bases in chemistry, if you've taken it. We use the pH scale to measure the acidity or basicity of a chemical. The pH scale runs from like 0 to 14, where things, the small numbers are considered acidic. So like 0 through 7. Like batteries often have acid in them, depending on the kind of battery you have. Some of them, if you have a chemical battery, that is. There's other kinds of batteries, though, too. And then pHs from like 7 to 14 are considered basic. So like soaps are often basic. And then a pH of 7 is considered neutral, which is basically water, yeah, like deionized water. What?
Where's lemonade on?
I'm probably
Acidic.
good at 6.
Yeah. It's got citric acid in it. And probably some like ascorbic acid or vitamin C or something in there that's acidic also. But what pH is the concentration of H plus ions in a compound, right? So remember an acid like HCl, when you drop it into water, dissociates into H plus ions and Cl minus ions. It's the H plus ions that we're measuring measuring acidity with. And just like with earthquakes, it's like a base 10 scale. So something with like pH of 5 and pH of 3, well, the pH 5 thing has 100 times more ions in it, or H plus ions, than the other one does. All right, so let's do our example here. So funny that, Caden, you asked about lemonade, because the question is asked, or we're talking about, is lemon juice. Yeah, it's like the same thing. So a sour lemon is found to have a pH of 2.2, and a bottle of bleach is found to have a pH of 10.2. What are the hydrogen ion concentrations of the two items? So we have the pH, which is of lemon is 2.2. It's equal negative log H plus. So what I want to get is that concentration of H plus by itself. So the first thing I'm going to do is multiply both sides by a -1 to get the coefficient in front of the logarithms to just be a +1. And then what do I need to do to both sides to cancel the log? Base 10, yep. So those guys cancel out. And we'd say that 10 to the negative 2.2 is the concentration of the hydrogen ions. And these numbers should be small, right? Since,
0, 0.
yeah, most of it is water. So if I do the same thing then for the bleach, so the work here is going to be exactly the same, right? And I can see that all that happened was the negative of the pH became the exponent on a 10. So I'm just following the pattern of work that I did before to just shortcut through to that. Are you guys cool with what I did there?
Yeah, cool.
It just felt like, wowzers, that's a little number.
Yeah.
Was that 12, was it? I don't missed it. 11. So in part B, it says how many times greater is the hydrogen ion concentration of the bleach than that of the lemon. I think that that's a typo since it's like definitely not any greater, right? The lemon has more. So I think it was supposed to be hydrogen ion concentration of the lemon than the bleach. So I'm just going to do a ratio. Now, I could have taken those two numbers from my calculator, but I'm going to use the exponential because this is easy to simplify by hand, right? So once again, I'm just going to subtract the exponents. So you have a 10 and then 8 zeros after it. So the lemon has 100 million times more hydrogen ions than the bleach. Yikes! It's a lot, Mr. Kulik.
Yeah.
Yeah, man.
That's bad.
All right. Our last situation that we're going to talk about is cooling objects. So like if you've ever heated something up and then set it like, you know, like you cook something in the microwave and you set it on the counter to cool off afterwards. This equation here is kind of describing how that process works. So T, capital T, is the current temperature. So T of T is the current temperature after T minutes. So that's like a function. T sub M is the temperature of the surrounding medium. So most likely that's going to be the room temperature of the, you know, the room that you're, the temperature in the room that you're cooling the item off in. Or if you're like forging a sword in medieval Europe or something. It'd be like the water that you're dipping the sword into, like anneal the steel.
Yeah.
Um,
I do that on Sundays.
T naught is the initial temperature of the heated object. So like that's the temperature of the object when you finish heating it up. So maybe if you're boiling something, it's 212 degrees Fahrenheit. Maybe if you're like forging a sword, though, it could be like thousands of degrees.
Surrounding medium is like just surrounding the area.
The air, like the air temperature, like if you're dipping it in water, it'd be like the water temperature. Whatever, like wherever you're going to be cooling the object at. And then K is a constant. So K is specific to the substance that you're heating up. So like if you're boiling water, the K is going to be different than if you're heating up iron, right? Because those two substances hold on to heat at a different rate and let go of heat at a different rate. So that K is going to be specific to the substance that you're dealing with. Caden?
What did you say the T at the beginning was?
So capital T is the current temperature of the object. So T of T, like that function notation, is the temperature of the object at time T. And lowercase t is just time, typically in minutes. But that's really controlled by the constant. Again, typically that constant is a per minute constant. So I'm going to put up the example question, then I think it's time for lunch, and we'll just have to finish this when you guys get back. But we're going to be boiling some eggs.
No spill.
All right, have a good lunch. We should have been done this one first, so you guys would have known how long to leave your microwave sandwich out to cool before you're ready to eat it. But
Dude, I got here I tried to.
Is this your guys' class right now?
Yeah.
Well, I'm on. Take care. Nope.
Oh, my God. It wasn't like you, like, punching. Just aggressive.
oh, that's a problem.
How's your Wednesday? Good.
Oh, well, other than making a mess right now, it was all right.
Just go everywhere.
Yeah.
The
More concerningly, like onto the power slot on the laptop. Perhaps that avoided everything somehow. Maybe I got very lucky. Oh. I took my daughter to see the Mario movie.
Oh, that's so good.
Her favorite part was when he said "Mamma Mia."
Oh, yeah, I can see it.
Walking right past you guys. Just sit in the corner.
Oh, he's an assassin.
Sorry. Had to happen though. Sure, no problem. Everybody's 10 minutes late to the start of this class anyway, so what can you do? Should I get real upset or should I just let it go? I'm just going to let it go. Oh. Oh boy, it's a big long. I forgot to pause the thing before we left for lunch. It's gonna be a long video today.
30-minute pause.
Yeah, I'm gonna have to do some cropping on this one.
What's happening?
You let it run.
I forgot to let the recording go. Yeah.
What's it doing?
Yeah, take it. There we go, half.
Oops a daisy.
Are you scared? Why are you like, what?
Thanks for
Live left, I think.
taking
Yeah. Oh, actually, I don't know.
that. Nice try.
What?
Nice try.
I didn't even say anything. Yes, you did. Right in there. So dumb. Why?
All right, folks. Should we get this show on the road here?
Yeah.
Yeah, I think so too. The couple of people that aren't here yet are the ones that are perpetually late for all the time, so we're just gonna go. Olivia, we're talking about you.
Oh, she left.
Oh, even better.
Perfect.
Then I'm not waiting for him. All right. So we had talked about this Newton's law of cooling here, and we're just ready to start the example. So we say that a hard-boiled egg is heated to 96 degrees Celsius, bless you, is placed in a pot to cool. That pot is 16 degrees Celsius. I assume it's filled with water. Well, it says just like a cold, empty pot.
Yeah.
And it seems like water has to be in there, especially because that's usually how you make hard-boiled eggs. After 4 minutes, the temperature of the egg is 45 degrees Celsius. Find out how long it will take in total to cool the egg to a temperature of 20 degrees Celsius. Okay. So first things first, let's identify which of our parameters we're trying to solve for. So in the question, what is it asking us?
How long it will take?
Yeah. So what is that going to be? Yeah, we're looking to solve for a t. Great. Everybody feel okay with that? Since it said how long, it's obviously asking to solve for time. Okay? So now let's go through and start figuring out what some of these other numbers are. So what is the 96 going to be?
That's the TO.
Yeah, we pronounce that T naught, but I knew what you meant. So that's the temperature that the substance is heated up to. What's the 16?
The surrounding.
Yeah, the TM, the surrounding temperature, is the temperature of the medium. All of those would be okay. Okay. So we still have two more temperatures. We have 20 degrees and 45 degrees. What are those going to be then?
Is that 45 going to be the T? Or not the T, the K? What the K?
So yeah, the K is suspiciously missing. The K is not a temperature, the K is a constant. So K we're not given. Okay, good. So let's look at the 45. What would you say that 45 is? Big T of 4. Right? Why T of 4?
Because after 4 minutes instead of temperature.
Yeah. But the T of T that we're actually interested in is the 20 degrees. Is everybody okay with how we've gone through and kind of decoded that? All right. So when I look at this, I see 2 steps. I'm going to have to figure out what that K is. To do that, I'm going to use that T of 4 is equal to 45 degrees. And then once I have that value of K, I can then solve the problem that I'm really being asked to find that, to solve the equation T of T equals to 20. Everybody okay with that plan?
Yeah.
Okay. So for step 1, I'm going to have 45 is equal to 16 plus 96 minus 16 e to the negative k times 4. Is everybody okay with how I plugged that in? So the T naught and T of M are constant, right? Those are, regardless of whether we're in step 1 or step 2, those are going to stay the same. My T of 4 is 45. So the T, the little t, is 4. So I've just gone ahead and plugged that into the equation.
So this solving for K.
So now we're just going to be solving for K. Exactly right. So far, so good?
Yeah.
Okay. So to solve for K, let's see, what are we going to do? I'm going to start by subtracting that 16 over first. So 45 minus 16 is 29. 96 minus 16 is, I think, 80 though, right?
Yeah.
And then we'll divide both sides by 80. And then what are we going to need to do to get rid of that exponent base of E?
Gotta do that L and then L.
Yeah, the natural log. Great. So we'll do the natural log of both sides. Absolutely. And then the last step would just be then to divide by -4, right? I'm going to write it this way, just so I don't get confused about whether that divide by -4 is inside the logarithm or outside the logarithm. I'm going to write it as a -1/4 on the outside, just so it's really clear to me where that -4 is going. And then it's calculator time. So let's fire that bad boy up. And we have -1/4 times the natural log. So the ln button is on your calculator right below the log button. And then 29 divided by 80. So that's my K. I'm going to use that again in the next problem. So I'm going to store that value. And I'm going to store it into the letter K so I don't forget what it is. So I just pressed the STO button at the bottom, and I did alpha and the letter K. So now when I recall that letter K, that number is plugged in there, so I can reference it again later. Now we're on to step 2. So here we're going to say 20 is equal to 16 plus 96 minus 16, e to the negative 0.25, yada, 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 t. Or that's my value for k. So just like before, we'll subtract 16 from both sides, combine that 96, or do the 96 minus 16. And I'm just going to write kt. We're going to remember that we solved for k already. We know what that is. But I'm just going to write it as k because it's too many decimals, guys. Yuck. Divide both sides by 80. I acknowledge that I could reduce that if I wanted to. I just don't really feel like it because it's all going in my calculator anyway. So like, bleh, let the calculator deal with that. Just like before, we'll do the natural log of both sides to get rid of the exponent base e. And then I'll multiply or divide by negative k, or really I'm just going to do multiply by 1 over k. Again, just so that it's clear to me when I go back and I look at this where I'm putting that in at. So go to my calculator, negative 1 divided by k, so I'll call up that k, times the natural log of 4 over 80. And I got about 11.81 minutes. What if I wanted that in minutes and seconds? How would I turn 11.81 minutes into like 11 minutes and some seconds? Well, I'm going to subtract the 11 off, right? Because I know I'm going to say 11 minutes, and then just take everything left and call it multiply by 60. So I'd say, or you could call that 11 minutes and we'll round up to 49 seconds. Either way would be okay. And I think at this point now you can do up to 138. So there's, 8 more problems or something. Mm-hmm. What do you guys think there? It's okay? Again, this stuff shouldn't have been too difficult, right? We're just like, here's a new equation to describe a situation. All we have to do is be able to read the story problem, pull out the parts for the equation, plug them in, and then it's just like a solving problem that we've been doing, right? Did you guys have homework questions you wanted to talk about? Let's knock some of those out. I know Bloom, you were saying?
Now you're getting a sip of water.
Yeah, just one sip though, man.
Just one?
Just one.
127.
127. Okay. Oh yeah, this will be some tricky ones down here.
Yeah, I was struggling first ever.
Yeah. Well, you would have had to use you'll have to use the quadratic formula in this. Wait.
21 all the way up to here. I struggled with 122.
Okay.
So what is the homework set to Sunday?
Let me go back and double check that. I'll get back to you in just one second. I want to get through this and then I'll go look and see what it was that I wrote down, if it needs to be adjusted at all. So the first order of business, I'm going to condense this stuff. So natural log of the square root, x plus 3. Let's just write it this way. Over x is equal to 0. Everybody okay with how I condensed that? Okay. Then I use the exponent base e to both sides. So that's going to cancel out the natural log. And e to the 0 is just 1. And then let's, I'm going to cross multiply. So I get square root x plus 3 is equal to 1, or equal to x. So I just did like one of those. And then we're going to square both sides to get rid of the square root. And what I'm left with now is a quadratic equation. And I notice that there aren't two numbers that multiply to give me -3 and add to give me -1. So I'm going to apply the quadratic formula. So negative b plus or minus square root b squared minus 4ac all over 2 times a. So I have -1 plus or minus, oops, I'm sorry, it should be +1. Plus or minus 1 minus a -12 is 13 over 2. So that's my answer. But I still need to check to see if either these are extraneous. So if I take a look at the first one, clearly that's a positive number, right?
Yeah.
So if I go up here, if I plug a positive in here or a positive in there, either is good, right? So that's no problem. If I look at the second one, the square root of 13 is going to be a bigger number than 1, right? So 1 minus the square root of 13 is going to be negative. I don't really care what the number is, I just care that it was negative, because when I plug it back in here, that's going to be the problem, right? So that one's extraneous. We'll discard this one.
Well, in the first place, wouldn't it be already, could it be not just due because it's could be a negative?
Well, if you had like x plus 7 and x plus 8,
Yeah.
if that's a negative, it's possible that when you
Yeah.
add the 7 to it, you still end up with positive. Right. So like just the fact that it's negative isn't enough for me to just discard it out of hand.
All right.
But in this situation where I had just like a log of x,
Yeah.
then I know that a negative is going to be a problem for me. Does that feel okay with what we did there?
Yeah.
Okay. You said you had another one though?
128.
128 also?
I'm assuming that's very similar to this one.
Yeah, a little bit. Eventually they all kind of, yeah, kind of the same. Most of them end up in a quadratic at some point. So again, same idea. I'm going to condense this. So I'm going to end up with log of x over the square root of x plus 4 equal to 1. And to get rid of the log there, I'm going to have to use exponent base 10. So I got this. I'm going to just kind of do my cross multiplication thing. So I have that. And then to get rid of the square root, I'm going to square both sides. So when I square a product like that, I have to square the 10 and then the square root. So I'm going to get that. And then I'll distribute the 100 through. and move everything onto one side. And maybe there's two numbers that multiply to give me negative 100 and add to give me negative 400 and add to give me negative 100. But I can't think of them right off the top of my head, so I'm just not going to try too hard on that. I'm just going to go straight to the quadratic formula because, boy howdy, seems like there's going to be a lot of possibilities there. And I don't even know if I'm guaranteed to find one. So I'll just pass on all that nonsense and just go straight to here. So 100 squared is 10,000, and then plus 1,600. So that's going to be 11600. And that I can simplify. Let's actually even check to see if it's a perfect square. I doubt that it is, but no. Okay. So clearly I know that I can take out a factor of 10 because I can make that 116 and 100, right? So then I'm going to worry about the 116. That looks like it probably has a 4 in it. Yup. So I'm going to have 2 times 10 times the square root of 29. And I don't really technically need to do this step. This is just going to make life a little easier for me. So when I reduce this, I'm going to get 50 plus 10 root 29. Or 50 minus 10 root 29. And again, the first one should be fine because everything in there is positive. The one that I care about or that I want to be careful about is this second one. And really what I want to know is 50 minus 10 root 29 going to be negative or not. Now I can look at this and tell that it is, since square root 29 is bigger than square root 5 or square root 25. So this is bigger than 50. So again, because I have this guy right here, I know that that negative is going to be no bueno. So we just cross that one out as extraneous. We're left with just the one answer. That feels okay? Oh. Anybody else? If you change your mind, you can always come up and talk to me individually. But I think I'm out here for the rest of today.
He's out.
But feel free to pick up where you left off on your Delta Maths or continue on with your homeworks. Boyd, you had asked about what was the problem set due for Sunday. Let's take a look at what I wrote down and see if that jives with where we're at. Okay, so I had written down 99 to 138. Well, that's no good, right? That can't go past 30 or 130, right? Because we just got the 138 today. So let me update that. And then we need a delta math due, right? Because the delta math, I think, is, what number delta math is this? 5 or something?
Yeah, 5 or 6.
Something. We'll call it 5, and I'll go back and fix it in a minute. Okay. Oh, we already had Delta Math 5. This must be 6 then.
I got that last one.
Okay.
Scrapped it out.
And then we'll start. So you're up through 130 for Sunday plus the Delta Maths. And then for next week, we're going to have 131 to 138 as the start. And then we'll be adding on to that one. Was it on fire?
He's an electrician.
He's also
And when we got our cooler hot tub put in, they took out the circuit breaker for the dryer.
Mm-hmm.
We got a new dryer, so we can't get a dryer working.
So where was he this morning or was it this afternoon?
Somehow did it. I don't got exact details.
How did he know?
Because my mom's been
He was like, "Oh, you guys coming over to that?"
yeah, the math.